Really, Rolanda, I want noodles. Find out what that's all about as we learn how to classify real numbers in this video. We're going to start with the smallest set of numbers, and that smallest set of numbers is natural numbers. It's how you naturally count. When somebody says, okay, count to 10, how do you count to 10? You start with 1. That's how you learned when you were a kid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can keep going for forever, but these are the natural numbers. The next number set are all of the natural numbers and 0. When I think of whole numbers, I think of that 0 or that O right in the middle of whole. That tells me it's 0, and then all those natural numbers. So only difference between whole numbers and natural numbers is this 0. Okay, so now the next set of numbers is going to include all of these and some more. And those are called integers. Integers are all positive and negative whole numbers. So it's going to be those whole numbers. Notice 0 is in the list. And their negative versions. So from negative infinity over here, going to positive infinity over here. So those go on forever. Okay, after integers, what's the next set of numbers that includes all of these and some more? Well, those are rational numbers. Rational numbers can be written as a ratio of two integers. So any of those last numbers, those positive or negative whole numbers, written as a fraction together, so one over the other. You can always take fractions and turn them into a decimal, and if it's written as a decimal, the decimal either ends or repeats. Think rational with the word ratio in it. And then remember, a ratio is just a fraction. So any number that can be written as a ratio is rational. Here are some examples. 4, because 4 over 1 is rational. 1/4, hey, that's already written as a ratio, 1 over 4. 0, okay, 0 over 5, 0 over 10, 0 over -1, it's all equal to 0. -2 and 1/10. And when we say our mathematics properly, we can tell -2 and 1/10. There we go. It's now written as that ratio or fraction. Let's see, our next number here is a repeating fraction. And remember, that's okay, because the decimal either ends or repeats, and it's kind of a complicated way to figure this out, but this happens to be equal to -1/9. So that repeating fraction, repeating decimal can be written as that fraction, which makes it rational. So if you just remember, if the number ends or it repeats, it's rational. Let's see, the opposite of rational is irrational. Irrational numbers cannot be written as a ratio. When they are written as a decimal, the decimal never ends and it does not repeat. Think of those people who just talk and talk and talk and talk and talk, and they just might talk about what they had for lunch, and then they're going to talk about who they're having for dinner, and oh my gosh, did you know it's the sunniest day of the year today, and oh, you should have seen what the cat did last night. Those conversations that go on and on and on, you don't know what they're going to say next, and that's irrational. Okay? Numbers that go on and on and on forever and do not repeat are irrational. Kind of like those conversations you might have with some unnamed people. All right. When you take a square root and turn that into a decimal, often, not always, but often, square roots are irrational, and pi is always irrational. Pi goes on forever and does not repeat. So let's see some examples of irrational numbers. We've got, well, this one is hidden from us. It is 4.10, 110, 1110, 111, ... which means that goes on. I know what that pattern is. It's adding another 1 every time. So that would be 0, 1, 1, 1, 1, 1. But let me see, that's supposed to be irrational. And it's because it does not repeat. We could not put a repeat bar over this, even though we know the pattern. Okay, so that's why that one is irrational. The next one is pi. Any number with pi in it, 5 pi, pi divided by 3, that is always going to be irrational. Square root of 5 or radical 5 goes on forever. If you were to put that in your calculator, you could see that for yourself. And this number here, no repeats, ... means that number goes on forever. If there were no dots, if these dots were not here, that means that number would end. That would make it rational. But since they are there, it doesn't end, so it is irrational. Okay, those are all the different kinds of numbers that you're going to learn about for most of this year, and they are all categorized as real numbers. So all of the numbers that are rational or irrational, they are all real. So every number we've talked about today is real. Just as some bonus learning, all unreal numbers are imaginary numbers, kind of like those friends you had when you were a kid. For instance, the square root of -9. That is irrational. That is imaginary, not irrational. This is imaginary because there's no number that you multiply it by itself to get -9. Okay, -3 times -3, that's going to give you a +9. So this is equal to 3i, imaginary. Okay, but again, that's just bonus learning. Now we get to really, Rolanda, I want noodles. Why am I telling you this? Because it's a way to remember the order of the set of real numbers. We have real numbers, rational numbers, integers, whole numbers, and natural numbers. And what you're going to do is you're going to have to classify these numbers. So you're going to write this out on your paper, and I'm going to think, okay, really, Rolanda, I want noodles. And then I'm going to write out the rest of the word on my paper when I take a test or quiz or I'm doing homework. And I'm going to start at the bottom and I'm going to go up and I'm going to see what number sets all of these numbers belong to, because one number probably belongs to more than one set. Okay, so we're going to remember that, really, Rolanda, I want noodles. And we're going to have this here, and we're going to write down what number set this belongs to. And we're going to start at the bottom and go up. So pi. Oh, right away, that's irrational. Irrational is not on this list because it is off by itself. If it's irrational, it is only irrational and real. Okay, 1/2. Is it natural? No, we don't naturally count. Is it whole? It's not 0, 1, 2, 3, 4. No. It's not an integer. It's not positive or negative whole numbers. Is it rational? It's written as a ratio. Yes. So that means that this is rational. And once it's one thing, it's everything above it. So it's also real. The square root of 3. Put that in your calculator. No repeats, goes on forever. So that is irrational, but all irrational numbers are also real. Okay, let's go with 5. 5 is Natural, yeah, we naturally count. So 5 is all of them. So I'm just going to put the first letter. It's natural. If it's natural, it's also a whole number. It's included in 0, 1, 2, 3, 4, 5. It's an integer, it's rational, and it's real. Okay, let's start at the bottom again. When it comes to 7/10 repeating, 0.77777, we don't naturally count. It's not included in 0. It's not a positive or negative whole number. Okay, so it's not any of those. But is it rational? It repeats. It is. And it's also real. Okay, let's look at 0. Do we naturally count to 0? If I say, hey, hide and go seek, I'm going to go over there. You know, you don't start at 0. You don't start at 0, so it's not natural. But is it whole? Yeah, look at that 0 there. So it's whole, which means it's also an integer. It's also rational, and it's also real. Okay, -4. You don't naturally count to negative numbers. It's not 0, 1, 2, 3, 4, but it is an integer. So it is an integer, it is rational, and it is real. So if you memorize, really, Rolanda, I want noodles, you remember to start at the bottom, work your way up. Once it's one of them, it's all of them. You're going to be able to classify these numbers, no problem.